a system like this, and I have a force acting on it. Let's call this F1 at a distance D1 from here. And I have another force here, F2, at a distance D2 from here. All right. This force here is trying to push this in this direction, that is clockwise. That is clockwise. So this F1 produces a turning effect in the clockwise direction. And this F2 here is trying to produce a counterclockwise moment which goes in this direction. We call it anti-clockwise moment, ACW. So for this to be in equilibrium, the clockwise moment produced by this force has to be equal to the anti-clockwise moment produced by this force. So this is the condition for equilibrium that are going to be used in solving questions like this one. So let's begin now with our solution. The diagram shows a uniform meter rule AB which balances horizontally at 90 cm mark, as you can see, when a mass of 0.2 kg is suspended from B, which is the airstream, that's 100 cm. Calculate the mass of the meter rule, that is M1. So we're looking for M1. So let's begin at our solution. So write solution. The 0.2 kg is producing clockwise moment, as you can see. It's trying to turn this meter rule in this direction. And let's look at the distance from where it is to the balance point. This 90 cm is the balance point, and it is at 100 cm. So between 90 cm and 100 cm, we're going to have 10 cm. So that is its distance, the distance of this 0.2 from the balance point. So that will give us the clockwise moment when we multiply this and this 10. Similarly, the mass of the meter rule is at 50 cm because we are told it is a uniform meter rule. So it's at 50 cm and the balance point is at 90. So from 50 cm to 90 cm, that's a distance of 40 cm. So that gives us the distance of M1 from the balance point. So for this to be in equilibrium, as we have established, the sum of clockwise moment should be equal to the sum of the anti-clockwise moment. This 0.2 kg produces clockwise moment, and the moment, as we know, is product of force and distance, the perpendicular distance. So this is going to be 0.2 times 10. Now, there's no need converting this 0.2 kg to weight and converting this from cm to meters because it will still cancel out in both sides. So this will be equal to the anti-clockwise moment, which is this M1 and 40. So we're going to be having M1 multiplied by 40. So 0.2 times 10 gives us 2, and this is going to be equal to 40 M1. We're going to have 2 over 40, and this is going to be 1 over 20. So M1 will give us 0.05 kg. So the mass of this meter rule is 0.05 kg, and that is option A. So option A is correct. Also given this to solve. This question says the figure above shows a seesaw which is perfectly balanced. The weight of people sitting on it are 50 kg, x kg, and 15 kg as shown. Then sit at distances 1.5, 1.5, and 2 meters from the pivot respectively. The value of x is what? And these are the options. So let's go straight to solution. So write solution here. We're going to say for this, since it is balanced perfectly, this statement balanced perfectly, what it means is that sum of clockwise moments should be equal to the sum of the anticlockwise moment. So let's look at the diagram. Two people are here to the right, and their weight is trying to turn this ruler clockwise. So these two people here are producing clockwise moment. This person is also producing clockwise moment. And only this one is producing anti-clockwise moment. So sum of the moment produced by these two people should be equal to the moment produced by this one. So sum of clockwise moment will be, let's begin with the one weighing 15 kg. It's going to be 15 kg multiplied by the distance of the 15 kg from the balance point. So the distance is given to us as 2 meters. So we're going to have 15 multiplied by 2 plus, that is moment of this guy, plus the moment of this guy. The weight of this guy is given to us as s kg. So it's going to be x multiplied by, let me use small letter x multiplied by 1.5. That gives us the moment produced by this person. And this equal to sum of anticlockwise moment. The anticlockwise moment is this 50 kg. So it's going to be 50 kg multiplied by the distance of the 50 kg, which is 1.5. So we're going to have multiplied by 1.5. So this will give us 15 times 2 gives us 30, plus this will give us 1.5x, and this will give us what? 75. To give us 75. Transfer this 30 to this side. So we'll have 1.5x to be equal to 75 minus 30 in the other side. So 1.5x will be equal to 45. Okay. So when we divide both sides by 1.5, so we'll get our value of x. So this is divided by 1.5 divided by 1.5. So our x value will be 45 over 1.5. 30 kg for the weight of this guy to be able to balance this seesaw. And that is option A. So option A is correct. We need this guy to be weighing 30 kg.